Searching for life beyond Earth has only just begun. Science has a promising early answer. There are many planets in our galaxy. Many observations, both from the ground and in space, confirm thousands of planets outside our solar system. There are likely trillions of planets in our galaxy. We have not yet found any evidence of life outside Earth. Is it easy to start living in the universe? Is it rare or easy to start? Here are some theories about aliens. Extraterrestrial life exists. The theory that life is found elsewhere. It is possible that life exists in the universe and even within our solar system. Mars and some of Jupiter's moons could have microbial life. Saturn. On planets orbiting Saturn, for example, intelligent civilizations and more complex life forms could exist. The Fermi Paradox asks, if intelligent life is widespread in the universe, then why have we not detected any evidence? Some theories claim that intelligent civilizations are more likely to self-destruct. Others suggest they're too far away or don't want to communicate. Ancient aliens. This theory proposes that aliens visited Earth in ancient times and influenced human culture and history. This theory points to ancient texts and artwork as proof of alien invasion. UFO sightings. Unidentified flying objects are often cited by aliens as proof of their visitation. Many sightings are explained by natural phenomena or human-made objects, but some remain unexplained. These could be evidence of extraterrestrial visits. This theory, or the simulation theory, proposes that all of our reality is actually a computer-generated simulation by an advanced civilization. This theory, while not specifically about aliens, suggests that the creators could be an extraterrestrial civilization. Let's start at the beginning. Let's start with the most basic of questions. Do aliens exist? According to the Drake equation developed by Frank Drake in 1961, intelligent life is likely to exist elsewhere in the universe. The equation considers factors like the number and type of stars in the galaxy, planets with the potential to support life, and the likelihood of life developing on these planets. The Drake equation, based on these factors, estimates that there may be millions of intelligent civilizations in just our galaxy. The question is, have we ever met these civilizations before? There are many people who believe we have. There are also countless stories about alien abductions, encounters, and sightings. There is no concrete evidence that these claims are true. Let's look at some of the popular theories of what aliens may look like.
T-10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build.
It is highly unlikely that aliens will look like this. It is difficult to predict how aliens will look because their appearance depends on the conditions on the planet where they evolved. Aliens that evolved on a high-gravity planet might be shorter and stockier. Those who evolved on planets with harsh radiation environments might have developed more resistance to radiation. Some alien species may not have any bodies at all. It's possible that they exist as pure energy or as a collective hive mind. But why would aliens visit? There are several possible reasons. Scientists speculate that our planet's unique position in the universe might make aliens interested. Earth is located in a Goldilocks zone. The climate is just right for life. It's not too hot or too cold. Aliens may be interested in our planet because they want to know how life can thrive in such conditions. aliens might also visit Earth to contact us. There are many intelligent civilizations out there, and it is possible that they are trying to reach us. If this is true, then they may be communicating in a way that we cannot even understand. They may use a different method of communication than we do. What should we do in the event that we encounter aliens? Scientists advise us to approach any alien encounter with caution. We should avoid any sudden movements and aggressive actions, as they could be misinterpreted. We should instead try to communicate peacefully and without threatening words. Contact with aliens could have a profound impact on our understanding of the world. It could force us to rethink our beliefs about our place in our universe and confront some of life's biggest questions. We've now explored the theories and possible alien life. Consider the Fermi Paradox. This paradox asks, if there are intelligent civilizations on other planets, why have we not seen evidence of them? Why have we not detected any signals from other planets or observed any spacecraft? One possible explanation is that advanced civilizations tend to self-destruct. With technology comes destruction, whether it be through war, environmental damage, or other disasters. It is possible that intelligent civilizations will reach a point in their evolution where they can no longer sustain themselves. They may fail. It's also possible that intelligent civilizations don't want to contact us. Maybe they don't care about Earth or communicating with other species. Perhaps they are too distant to detect our signals, and we are too primitive to detect them. The Fermi Paradox is a mystery, and it remains so despite the many theories. Let's now turn our attention towards the possibility of life within our solar system. We haven't yet found evidence of intelligent life on any other planets or satellites, but there are promising signs that microorganisms may exist. NASA's Mars rover, for example, detected methane at the surface of the planet, which may be an indication of microbial activity. Scientists have discovered evidence of subsurface seas on the moons of Jupiter and Saturn, which may support life. It would be a significant discovery if we were to find evidence of microbiological life within our solar system. This could have profound implications for our understanding of life in the universe. Consider the implications of finding intelligent life. Contact with aliens could have a profound impact on society and our understanding. One of the most important things is that it will challenge our current worldviews and beliefs. We may need to re-evaluate our views on our place in space. We may need to rethink our religious and philosophical beliefs and how we view the origins and development of life. This could raise ethical questions regarding the interaction with intelligent species. A second potential impact could be on our technological and scientific progress. We could potentially accelerate our progress if we encountered a civilization that was more advanced. It could be a danger if aliens are hostile towards us. It is difficult to know for sure if aliens are dangerous to us. There is no evidence that intelligent life exists outside of Earth. Therefore, any speculations about their behavior or intentions are purely hypothetical. Some people believe that aliens are dangerous if they have more advanced technology than we do and can conquer or destroy us. Some people argue that aliens could be dangerous if they are more technologically advanced than us and have the ability to conquer or destroy us. You could also imagine that aliens are indifferent towards us, observing us from far away without intending to interact. While it is fun to speculate on the possible dangers of aliens, we don't have enough information to draw any conclusions about their behavior or intentions. The search for extraterrestrials should be approached as a curiosity and with an open-minded approach, rather than with fear or paranoia. The search for intelligent life will continue, despite the possible impacts. We are always developing new technologies, and improving our techniques to search for signs and evidence of alien civilizations. While the odds of discovering intelligent life are slim, the pursuit and discovery of knowledge are important endeavors. Venus has a size that is almost identical to Earth, making it our closest neighbor in the solar system. It has a radius of approximately 3,760 miles, 6,052 kilometers. It is approximately 95% as big as Earth. Its mass is approximately 81.5% of Earth. Venus and Earth have a similar mass, size, and density. Venus has approximately 5.24 grams per cubic centimeter. This implies a similar rock-iron composition. Venus and Earth share a similar structure. A central iron core is surrounded by a rock mantle and a thin layer of crust. The iron core's diameter is approximately 2,000 miles, 3,200 kilometers. Venus's silicate mantle extends to about 1,550 miles away from the planet's core. A thin crust, estimated at 6 to 12 miles in thickness, is then placed on top. Venus' rotation is unique among all the planets in our solar system. Venus rotates the other way around. Scientists are still trying to understand this phenomenon. Some scientists believe that it could be because of a collision with another celestial object in the past. This may have altered the rotational dynamics of the planet. Venus rotates very slowly, with a sidereal year. A full rotation around its axis takes 243 Earth days, making it the slowest planet in our solar system. Venus has a slow rotation, which contributes to its lack of a magnetic field. Another oddity of Venus's rotation is that the time between sunrises on Venus is shorter than the sidereal day. Its retrograde rotation and its orbit around the Sun. The solar day of Venus is approximately 116.75 Earth days. The planet's year. It takes about 25 Earth days to complete an orbit around the Sun, which is less than its sidereal day. Venus is one of only a few planets whose day is longer than its year. The surface gravity of Venus is approximately 90% of that of Earth's surface gravity. If you could stand on Venus, you would feel lighter than you do on Earth. The extreme pressure and temperatures would make it impossible to live without protection. Venus' surface is geologically very young. The relatively few craters indicate that the surface age ranges between 300,000 and 600 million years. Scientists believe Venus is undergoing a cyclical heat-driven process that causes its surface to be repaved. It is clear that there has been widespread volcanic activity on Venus. There are thousands of volcanoes on its surface. They range in size from less than 1 mile to more than 150 miles. This planet is home to more volcanoes than any other in the solar system. There is no proof that these volcanoes remain active. Recent studies have suggested that some volcanoes may have erupted in the past few million years. However, Venus does not experience the same tectonic movement as Earth. Venus has mountain ranges, a rift valley, and a rift valley that are similar to the tectonically active regions of Earth. However, it does not have large, distinct plates like our planet. It could be because of the planet's slow rotation, which reduces the Coriolis force needed to generate large-scale tectonic activity. The atmosphere of Venus is its most unique and fascinating characteristic. Carbon dioxide is the main component of the atmosphere. The majority of the atmosphere is nitrogen. There are traces of sulfur dioxide, water vapor, carbon monoxide, and helium. This composition is very different from Earth's nitrogen-oxygen atmosphere. It makes the air on Venus toxic for humans and other known life forms. The troposphere extends from the surface of Venus to approximately 40 miles above. The mesosphere stretches from the troposphere up to 56 miles, and the thermosphere reaches 125 miles. Above that, the exosphere merges into the void of space. Venus' high carbon dioxide concentration creates an intense greenhouse effect that traps heat, making it the hottest planet in the solar system. Mercury, which is closest to the Sun, is even hotter. The greenhouse gases absorb heat. The Sun's energy is radiated, which prevents it from escaping into space. Surface temperatures are around 467 degrees Celsius on average, which is hotter than lead. The thick atmosphere is responsible for the low temperature variations between night and day or between the equator and the poles. The result is a constant temperature on the surface of the planet. Venus has a huge atmospheric pressure. Sea level is approximately 92 times higher than Earth's. It is the same pressure as 0.62 miles down in Earth's oceans. Without protection, a human would be crushed by such pressure. This is despite the fact that Venus' atmosphere is approximately 31 miles above its surface. Pressure and temperature are comparable to Earth's surface. Venus is permanently covered in opaque, thick clouds. The clouds are responsible for reflecting 75% of sunlight back into space. This is why Venus appears so bright from Earth. Venus's upper atmospheric winds reach speeds of up to 450 miles an hour. This is much faster than Earth's strongest hurricane winds. Superrotation is a wind phenomenon whereby the air rotates faster than the surface of the planet. Waves are slower near the surface. They usually travel less than a couple of miles per hour. Maxwell Mountains are the highest mountains in the solar system, rising up to 20 kilometers or 12 miles above the mean surface of Venus. Venus' surface is marked by impact craters and extensive lava flows, as well as unique features such as coronae, circular structures caused by hot material rising from the mantle. Venus does not experience the same level of seismic activity as Earth. However, new studies indicate that Venus could still be geologically dynamic. Since the beginning of space exploration, the Soviet Union's Venera and Vega missions, NASA's Pioneer Venus, and the European Space Agency's Venus Express have all made significant contributions to our understanding of Venus. The Venera program has achieved many firsts, including the first device created by humans to enter the atmosphere of another planet and the first successful landing on another planet. These missions collected valuable information about Venus's surface and atmosphere. More recently, NASA's Magellan orbiter used radar to map almost the entire surface. The mission was successful in revealing details about Venus's geology and surface features, despite the harsh conditions on Venus. Scientists want to explore the planet further. NASA's Veritas mission and Da Vinci Plus mission are aimed at studying Venus's geologic history, atmospheric conditions, and whether it once had liquid water or even life. Planet Venus is a fascinating world of extremes. The harsh environment of Venus presents significant exploration challenges. Yet its size and composition are similar to Earth and give hints about past geological and water activity. As we prepare to launch new missions to Venus, let's keep our curiosity alive. We are on the cusp of making major discoveries that could change our understanding of our solar system and how we fit into it. This will also have a direct impact on the future of our planet. Venus is both a warning and an opportunity for scientists to discover new things. The universe has always fascinated humanity. Jupiter, the largest planet in our solar system, is easily identifiable by its vibrant stripes and the Great Red Spot. Jupiter is more than just its famous storm and size. Our knowledge of Jupiter has increased exponentially as a result of advances in space technology. Jupiter is a giant gaseous planet mainly composed of hydrogen and helium. Its diameter is about 11 times larger than Earth's. It's so big that it could hold over 1,300 Earths. Jupiter's day is the shortest of all the planets that rotate on their axis. Every 9.9 minutes, Jupiter completes a full rotation. Jupiter has the strongest magnetic field of all the planets in our solar system. It is created by the electrical currents generated by its rapid rotation and the movement of metallic hydrogen within its outer core. Jupiter's bands, characterized by lighter-colored clouds, are high-pressure zones. In contrast, the darker areas of Jupiter are low-pressure zones. Different types of clouds are responsible for the vibrant colors. The white bands are created by ammonia crystals, while other chemicals create the reddish-brownish and yellowish shades. The Great Red Spot is an atmospheric high-pressure region that has been persistent for 300 years. Jupiter's Great Red Spot, the largest storm in our solar system, is easily recognizable. It is 1.3 times as wide at its largest point. Its size has changed over the years, but it is notable that in recent decades, its size has shrunk. It has been observed continuously since the late 19th century, but records indicate that it has existed for at least 300 years. The Great Red Spot can be found in Jupiter's southern hemisphere. It is located within the south equatorial belt jet stream and has a reddish color. Researchers are still trying to determine the chemical reaction that gives the spot this color. The storm rotates anti-clockwise over a period of 6 days. The storm's interaction with the surrounding areas can cause the rotation speed, color, and size of the spot to change. It is fascinating to see the Great Red Spot persist for so long. Storms on Earth can last days or even weeks. The Great Red Spot, however, has lasted for centuries. Jupiter's rapid spin and lack of solid surfaces, which reduce frictional dissipation, contribute to this longevity. The Great Red Spot is a window into the atmospheric dynamics of Jupiter. Jupiter is a gas giant with conditions that are vastly different from our own planet. This celestial storm not only reveals the secrets of Jupiter but also sheds light on broader principles governing atmospherics. Jupiter's four biggest moons, Io, Europa, Ganymede, and Callisto, are also known as the Galilean moons. They are named after Galileo Galilei, who discovered them in 1610. Each of these moons is its own world. Io is the planet with the highest volcanic activity in the solar system. Its surface is covered with sulfur and sulfur oxide, giving it a mottled, colorful appearance. Europa is covered in ice, and scientists believe it may harbor a subsurface sea, making it a potential site for extraterrestrial life. Ganymede is the largest moon in our solar system and the only one known to have a magnetic field. Callisto is characterized by a highly cratered surface, and it's also believed that there is an ocean beneath its surface. As of 2021, Jupiter's moon count was 79 when it was first discovered, but new moons could have been found since then. Saturn is not the only planet that has a ring system, although Jupiter's rings are much smaller and fainter. Jupiter's rings are mainly composed of dust particles that have been impacted by the planet's smallest, innermost satellites. NASA's Voyager 1 discovered these rings in 1979. Since Galileo made his first observations, the study of Jupiter has advanced significantly. Jupiter has been studied by multiple missions, including Pioneer 10 and 11, Voyager 1 and 2, Galileo, Juno, and others. Pioneer 10 and 11 were the first spacecraft to make a close approach to Jupiter. They provided valuable data on its magnetic field, radiation belts, and some of its moons. Voyager 1 made important discoveries, such as discovering Jupiter's rings and verifying Io's volcano activity. The Galileo orbiter studied the planet and its satellites for 8 years, and the probe attached to it made a direct dive into Jupiter's atmosphere, providing the first measurements of its composition. As of 2020, the Juno mission continues to study Jupiter. The 21st century has contributed significantly to our understanding of Jupiter's internal structures, atmosphere, and magnetic field. Jupiter's size, atmospheric complexity, numerous moons, and faint ringed systems make it an interesting object to study. We continue to explore Jupiter using telescopic observations and space missions. As we unravel its secrets, it enriches our understanding of the universe. Jupiter's presence is a testament to the complexity, diversity, and vastness of our solar system. We live in a galaxy called the Milky Way, which contains hundreds of millions of stars. Questions about our future and how we got here are intertwined with the study of galaxies. Each of the 200 billion galaxies in the known universe is vast, unique, and dynamic. Where do galaxies originate? What is their function? How will they evolve, and what is their future? Subscribe to our channel to stay updated with the latest videos on the universe. The Milky Way is our galaxy, and it's approximately 12 billion years old. A galaxy is a large disk with spiral arms and a central nucleus. This is just one of the countless galaxies that exist in the universe. First and foremost, galaxies are vast collections made up of stars. A galaxy can contain up to 100 billion stars. They are stellar nurseries, where stars are born and eventually die. Stars in galaxies are formed from nebulas, which are concentrated dust and gas. Our galaxy is composed of billions of stars, many of which have planets or moons orbiting them. For a long time, we knew very little about galaxies. A century ago, we believed the Milky Way to be the only galaxy in the universe. In 1924, Edwin Hubble changed the entire situation. Hubble used the most advanced telescopes available at the time to observe the universe. From the 100-inch Hooker telescope at Mount Wilson near Los Angeles, he saw masses of light in the darkness. He realized that these were not just stars. They were star-filled cities and constellations that extended far beyond the Milky Way. Astronomers were shocked to their core. Within a year, we went from having the Milky Way as the only galaxy to having billions. Hubble's discovery is one of the most important in the history of astronomy. He found that there are many galaxies in the universe, not just one. This is the Whirlpool Galaxy. It is composed of over 160 million stars and is characterized by its swirling spiral arms. The stars of M87, a huge elliptical galaxy, also shine with a golden color. This is because it is one of the oldest galaxies in the universe. This is the Sombrero Galaxy. The Sombrero Galaxy's bright, massive core is surrounded by a cloud of gas and dust. All galaxies are visually stunning as they move across the universe, representing the fundamental building blocks of the cosmos. They resemble huge pinwheels. On a grander scale, galaxies are immense. We measure distances in miles on Earth, but astronomers measure distances in light years. Light can travel a certain distance in 1 year. The diameter of our galaxy is more than 100,000 light-years. We are currently located about 25,000 light-years from its center. In the grand scheme of things, we are still just a small dot. The Milky Way may appear enormous from Earth, but compared to other galaxies, it is actually relatively small. The closest galaxy to us is about 200,000 light-years across, making it twice the size of the Milky Way. M87 is much larger than Andromeda and the largest elliptical galaxies in our cosmic neighborhood. But M87 appears tiny in comparison to this 6 million light-year giant. I think 1011 is the largest galaxy found. It is 60 times the size of our Milky Way. Galaxies, as we all know, are vast and ubiquitous. But why is this? Astrophysics is fascinated by the origin of galaxies. The universe was created approximately 13.7 billion years ago with the Big Bang, a period of intense density and heat. At that time, there were no galaxies. The galaxies that formed, the stars that formed within those galaxies, and the galaxies that formed from those stars must have originated from this very early universe. After the Big Bang, the first stars began to appear. Gravity caused the first galaxies to form only 200 million years later. The Hubble Space Telescope played a crucial role in this discovery. Now we can observe the early universe when galaxies were just beginning to form. Hubble can see a multitude of galaxies, but the light we see from distant galaxies actually originated millions or even billions of years ago. We can only observe the distant past. It took so much time for their light to reach us that the Hubble Deep Field is a collection of fuzzy dots. These galaxies look very different from what we see today. These tiny specks are so faint that we can barely make them out. These fuzzy blotches of light actually represent millions or billions of stars coming together. The oldest galaxies can be seen as these barely visible blots. Around 1 billion years after the Big Bang, galaxies began to form. If we want to go even further back in history, we would need a telescope that is too big to be sent into space. Such a telescope would not only be able to identify the first galaxies, but also track their evolution. Galaxy and galaxy cluster formation may have evolved over time. All the galaxies that have formed since the universe was only a few 100,000 years old are now leaving their marks for us to see. Scientists can finally begin to answer questions about what the young galaxies looked like. Galaxies evolved from clusters into the complex web of systems that we see today. As far as we know, astronomers can observe this process. Star clusters developed into galaxies and clusters of galaxy clusters. They eventually coalesced to form superclusters. Early galaxies were filled with stardust, gases, and clumps. Modern galaxies appear to be neat and organized. How did tangled galaxies become so organized? Spirals or ellipticals? Gravity holds the key. Gravity is the determining factor in the structure of galaxies. In the center of most galaxies, there is a powerful and unyielding gravitational source. Our Milky Way also has a hidden supermassive black hole at its center. Over the course of more than 12 billion years since the first galaxies appeared, these stellar conglomerations have taken on many different forms. They can be spiral-shaped or giant ellipticals. There is still much we don't know about galaxies. Did spiral galaxies always have to be spirals? The answer is almost certainly no. Stars, dust, and gas are all mixed together in young galaxies, making them chaotic and disorganized. They start out as turbulent formations, much like the Whirlpool galaxy. Over billions of years, they gradually develop into more ordered forms. The Milky Way did not originate from a single galaxy, but from the gradual merging of several smaller objects, each with its own size and shape, forming the galaxy we see today. Gravity is the force that binds all these components together over time. It slowly draws the stars closer, causing them to accelerate and flatten into a disc-shaped structure. Massive spiral arms gather gas and stardust. This process has been repeated countless times throughout the history of the universe. While visually different, all galaxies seem to revolve around a central object, united by the force of gravity. Researchers wondered what could possibly change a galaxy's behavior. They found out that it was a supermassive black hole, not just any black hole. Supermassive black holes were first discovered by the extreme amount of radiation emanating from the center of some galaxies. These black holes devour the surrounding matter like a massive Thanksgiving feast. Supermassive black holes consume stars and gas. Some black holes consume their food so rapidly that they eject it into space in the form of beams. This phenomenon is called a quasar. A quasar is a signature of a supermassive black hole at the center of a galaxy. But what about the Milky Way? There's no quasar here. Does that mean there is no supermassive black hole? The key to finding a supermassive black hole at the center of our Milky Way is by observing the movement of the stars. The stars move in the same way as planets do around the Sun. What we discovered was a peculiar and violent environment near the center of our galaxy. Extremes abound. Things are moving at incredibly high speeds. The stars are swirling at tremendous velocities. It's unlike anywhere else in the universe. Photographs of stars in orbit revealed a fascinating phenomenon. The stars must have been traveling at speeds of 1,000,000 miles an hour or more. Only a black hole of immense size could possess the energy to sling large stars in such a manner. This curvature provided evidence that a supermassive black hole resided at the center of our galaxy. The black hole's gravitational pull is what governs the orbits of these stars. At the center of our Milky Way galaxy lies a massive black hole with a diameter of 15 million miles. But is Earth in danger? There is no risk of us being sucked into our supermassive black hole. It is simply too far away. The distance between Earth's surface and the supermassive black hole at the center of the Milky Way galaxy is actually 25,000 light-years, equivalent to many trillions of miles. So, for now, Earth is safe. Supermassive black holes are sources of immense gravity, but they are not strong enough to hold galaxies in place. According to the laws of physics, galaxies are expected to accelerate away from each other. What is preventing them from doing so? There must be something more powerful than a giant black hole, something waiting to be discovered. It is invisible and extremely difficult to detect. That something is dark matter. Astronomers have discovered supermassive black holes at the centers of galaxies, which are responsible for the rapid movements of stars around them. However, these black holes alone are not sufficient to hold all the stars together in a large galaxy. What is keeping them together? A maverick scientist proposed the existence of an unknown force. Fritz Zwicky, a Swiss astronomer, pondered in the 1930s why galaxies were clustering together. He believed that they did not possess enough gravity and should have been flying apart. The force of gravity, as we understood it, was insufficient. He concluded that there must be something new, something never before considered. He called it dark matter. Fritz Zwicky, born in 1898, was decades ahead of his time. That's why he was highly regarded in the world of astronomy. It was a brilliant concept, and he was right. It is possible that the mysterious substance Zwicky called dark matter is what holds individual galaxies together. Dark matter acts as a scaffolding for galaxies, preventing them from collapsing or dispersing. Today, scientists are discovering that dark matter can do more than just bind galaxies. Scientists believe that the Big Bang may have triggered the formation of dark matter. Clumps of dark matter began to cluster, eventually evolving into the nuclei of galaxies. The nature of dark matter still eludes physicists. Dark matter is an enigmatic substance, and we have no knowledge of its composition. It is clear that it is not made of the same material as humans. You cannot touch it. You cannot feel it. It may exist as an ethereal substance that permeates everything, passing through you as if you were not even there. Despite our limited understanding of dark matter, it appears to be ubiquitous throughout the universe. In fact, there may be 6 times more dark matter than regular matter. Observations of its effects have led to the indirect detection of dark matter in deep space through gravitational lensing. Gravitational lensing can be used to test the existence of dark matter by observing how light from distant galaxies bends as it passes through regions of high gravitational influence, such as those created by dark matter. The gravitational pull of dark matter causes light to deviate from its original path, resulting in stretched and distorted appearances of distant galaxies. By carefully studying these galaxies, we can estimate the density of dark matter present. Dark matter's significance in the universe is more apparent than ever. Although invisible, dark matter prevents galaxies from collapsing. The cosmos is governed by dark matter. These galaxies may appear solitary, but appearances can be deceiving. The placement of the Milky Way within the cosmic framework is still a mystery. From the image, you can see that the Milky Way is part of a group of smaller galaxies, totaling about 30 in all. Andromeda and our galaxy are the 2 largest members of this group. However, further observations reveal that our galaxy is nestled within the Virgo supercluster. Researchers are currently mapping galaxy groups and superclusters to better understand the cosmic web of galaxies and their vast empires of stars. These galaxies come in a range of sizes, from colossal spheres to intricate spirals. As we gaze out into the cosmos, we witness their constant evolution. It is easy to assume that our galaxy remains unchanged, but that is not the case. Its fundamental nature has shifted over cosmic eons. Galaxies not only evolve over time, but they also interact with one another. Sometimes galaxies collide, and they also move. If two galaxies collide, they are likely to merge after millions of years. Such collisions are commonplace in the ever-changing cosmos, and the Milky Way is no exception. Our Milky Way is on a collision course with the Andromeda Galaxy. This is not good news for our galaxy, as we are hurtling through space at a speed of around 250,000 miles per hour. In approximately 5 to 6 billion years, the Milky Way will collide with Andromeda. The Milky Way galaxy is over. If you were to look out into space, you would see the entire Andromeda galaxy hurtling towards us at a great speed. As the two galaxies interact and move closer to each other, they become increasingly disturbed. The dance between the two galaxies will lead to their demise. When galaxies collide, they emit clouds of dust and gas in all directions. During these galactic collisions, stars are flung into the void by the combined gravity of the galaxies. It would be a spectacular sight as we approach the end of the Milky Way galaxy. It is inevitable that the Milky Way will merge with Andromeda. The resulting entity, often called Milkomeda, will appear and resemble an entirely new galaxy. What does this mean for planet Earth? As the arms of the Milky Way galaxy are torn apart, we may be flung out into outer space or end up in a different location within the merged galaxy. The stars and planets will be jostled around. This could potentially spell the end for planet Earth. However, all galaxies will continue to collide. The era of galactic cannibalism is coming to an end, as the universe holds a more destructive force. It is a force that cannot be stopped. Researchers have discovered a new power in the universe. It is called dark energy. Unlike dark matter, dark energy has the opposite effect. Dark energy pushes galaxies away from each other rather than bringing them together. The nature of dark energy, which dominates the entire universe, remains a mystery that was only discovered within the past decade. We have no idea why it is called dark or what its true nature is. We are simply aware of its presence. Our understanding of dark energy is still limited, and it is truly bizarre. It is as if space itself has tiny springs, causing things to resist and push away from each other. Scientists believe that dark energy will ultimately triumph over dark matter. With this victory, galaxies will begin to drift apart. Dark energy will eventually lead to the demise of galaxies. This will be achieved through the accelerated expansion of the universe, which will cause all galaxies to move away from us and become increasingly distant, eventually becoming invisible. They will then travel faster than the speed of light. Everything else in the universe will gradually disappear before our very eyes. It may not happen today or tomorrow, but over a period of trillions of years. The vast void will leave galaxies isolated. However, this process will take an incredibly long time. The cosmos is currently in a healthy state, and galaxies provide favorable conditions for life to continue to thrive. Without galaxies, we would not exist. It is possible that life itself would not exist. We are fortunate that our tiny solar system formed in the right region of the galaxy, allowing life to evolve on Earth. If we were closer to the center of the galaxy, it would be a dangerous place for life due to its high radioactivity. On the other hand, if we were too far from the center, there would be fewer stars, potentially preventing the existence of life as we know it. In a way, we are situated in the Goldilocks zone of the galaxy, where conditions for life are just right. Within this Goldilocks zone, there could be millions of stars, offering ideal conditions for life to thrive. If our galaxy can support life, it is reasonable to assume that other galaxies may also be capable of doing so. It is incredible that even as we think we have solved a puzzle, we continue to learn more about the cosmos and realize that the puzzle is part of a much larger picture. It is truly awe-inspiring. The Milky Way galaxy and other galaxies are full of mysteries and unanswered questions. Who would have predicted 20 years ago that we would identify the black hole at the center of our galaxy? Who would have predicted that dark energy and dark matter would become accepted concepts in the astronomical world? We should be amazed to be alive in this moment of cosmic history. Planets begin their formation on this planet, at the edge of this galaxy. With the ability to ask questions and seek answers throughout the vast expanse of the cosmos, planets have their own remarkable stories to tell. The early history of planets was tumultuous, and the same processes were at work in their creation everywhere. They were born, they evolved, they collided, and eventually they died. The Milky Way has been a fortunate home for intelligent life, and our fate is intricately tied to that of each galaxy. Ultimately, our destiny lies in the hands of those who created us and continue to shape our identities. We used to only be aware of the planets orbiting our own sun, but now we know that there are also rocky worlds and massive gas clouds surrounding other stars. These planets have incredible stories to share. The early history of planets was violent, and the same processes that shaped our solar system occurred elsewhere. A cloud of dust and other materials remained after the birth of stars, and it is from this cloud that all 8 planets in our solar system were formed. All the planets in our solar system are made from the same building blocks. The same cloud of gas and dust gave rise to the worlds within our solar system, but their formation conditions varied greatly. Some planets formed closer to the Sun where temperatures were higher, while others formed farther away where temperatures were lower. These differing conditions resulted in the diversity of planets that we observe today. At the dawn of the solar system, the mix of materials was fairly equal. Silicates, hydrogen, water vapor, methane, and various other substances were present. The dust cloud is akin to the ingredients of a cake. The way they come together depends on the mixture and the temperature. It is similar to how one would mix the ingredients for a cake. The mixture is then placed in the oven and baked, undergoing changes. This is essentially what happened in the formation of the solar system. The planets baked in slightly different ways depending on their proximity to the Sun. Close to the Sun, hot gases were emitted and water vapor evaporated, while metals and rocks were able to withstand the high temperatures. As a planet moved away from the Sun, only rocky planets could form. The process of planet formation varied depending on the distance from the Sun. To create rock-based planets, a cloud of metals and stones was needed. As the temperature cooled, the high boiling point substances began to solidify. Tiny mineral grains formed and gradually came together to create rocks and minerals. Over time, these particles started to stick together. Dust molecules collided and merged, forming slightly larger dust molecules. This process, known as accretion, continued as more dust molecules accumulated. The aggregates grew larger and eventually became rocks. These rocks collided with each other, forming boulders. The boulders then collided and merged to create even larger bodies. Eventually, an object grew large enough to exert gravitational pull, attracting more material towards it. Instead of simply colliding and growing in size, the object began actively pulling nearby material towards itself. During the early stages, there were numerous young planets within our solar system, possibly around 100. However, many of them did not survive. An example of a planet that did not grow large enough is Vesta, located in the asteroid belt. Vesta's diameter of 329 miles is not sufficient for it to become a spherical planet. Gravity then started to separate heavier elements from lighter ones. Heavier materials, such as metals, tended to sink towards the center, forming a denser core within the planet. The young planets gradually took on the characteristics of actual planets. However, they still had to endure a period of violence and destruction, which would determine their survival. After the formation of the Sun, approximately 4.6 billion years ago, the same cloud of gas and dust that created our 8 planets also contributed to their differences. There was no specific plan for each planet's creation. The rules of physics, chemistry, and other sciences governed the process, but much of what transpired was a result of chance and luck. Around that time, the Sun was surrounded by approximately 100 planets. It became a chaotic race, with most planets being eliminated. The early history of these planets was characterized by violence. As the planets grew in the final stages of their formation, collisions occurred, and some planetesimals began to dominate and absorb others. These planetesimals, which would eventually become planets, continued to grow by absorbing smaller bodies in their vicinity. This process resulted in space debris falling onto the surfaces of these protoplanets. In the end, only 4 rocky planets remained due to the turbulent history they experienced. The 4 rocky planets in our solar system, Mercury, Venus, Earth, and Mars, emerged as survivors of this intense period of collisions and mergers. Each planet developed its own unique characteristics based on its size, composition, and proximity to the Sun. The inner planets, Mercury and Venus, formed closer to the Sun where temperatures were higher, resulting in their predominantly rocky and metallic compositions. Earth and Mars, slightly farther from the Sun, also have rocky surfaces, but with more significant amounts of water and other volatile compounds. The formation of planets is a dynamic and complex process influenced by various factors. It starts with the condensation of dust and gas in a protoplanetary disk surrounding a young star. Over time, these particles collide, merge, and grow into larger bodies known as planetesimals. Through further collisions and accretion, these planetesimals develop into protoplanets, eventually becoming fully formed planets. The size, composition, and location of a planet within its solar system are determined by the interplay of gravity, temperature, and the availability of materials. Planets closer to the star tend to have higher temperatures, leading to the predominance of rocky compositions. In contrast, planets farther away can accumulate more volatiles, such as ices and gases, due to the lower temperatures. As protoplanets continue to grow, gravity differentiates the materials within them, with heavier elements sinking towards the core and lighter materials rising to the surface. This process, called planetary differentiation, leads to the formation of distinct layers within the planets, such as a metallic core, a rocky mantle, and in the case of Earth, an outer layer known as the crust. The violent collisions and interactions between protoplanets result in the ejection of excess material and the formation of debris disks, which can later give rise to moons, asteroids, and comets. Some of these objects may survive as remnants of the early solar system, providing valuable insights into the processes and conditions that shaped the planets. The study of planet formation not only helps us understand the origins of our own solar system, but also provides insights into the diversity of exoplanetary systems. Observations and data from missions like NASA's Kepler Space Telescope have revealed the existence of thousands of exoplanets, further expanding our understanding of planetary formation and the potential for habitable worlds beyond our own. From the chaotic beginnings of a dusty cloud surrounding a young star to the formation of diverse and dynamic planetary systems, the process of planet formation is a captivating journey that continues to unravel the mysteries of our cosmic neighborhood and the wider universe. Through ongoing exploration and scientific advancements, we strive to unlock the secrets of planetary origins and gain deeper insights into our place in the cosmos. All of them are so different. Mars is a frozen wasteland, while Earth has liquid water flowing through it. Venus is full of volcanic activity, while Mercury is small, hot, and empty because of an enormous crash. Mercury has a thin crust, and it is dense. It could have once been a larger planet. It was then that something struck it at an angle, tearing off the lighter crust to leave only the dense core. The young Earth, at the end stage of its evolution, was also hard hit. The mantle was ripped apart, and the pieces were sent into orbit. They reassembled on the surface of the Earth to form the Moon. Mars also appears to have been hit by something. The Earth's crust is thinner in the north than it is in the south. This could have been caused by the fact that early in Mars history, the northern hemisphere was struck by something that blew away a large amount of its crust. The crust then started to rebuild in the southern hemisphere. All these collisions had two effects. They reduced the number of planets still alive and brought more ingredients to those who survived. When you collide with something heavy or icy, the chunks tend to float around and become part of the crust. For rocky planets were nearly finished near the Sun. The planets were composed of a solid iron core, surrounded by liquid iron and a shell made of molten rocks. A crust is then added to the surface. These rocky planets are all made from the same materials, but they have very different shapes and destinies. The space may appear empty, but that's not the case. It's filled with stuff that's been blown by the Sun. The Sun creates strong magnetic fields. These fields are arranged in huge loops. They collide. The result is a storm of hot and charged particles that shoots into space. It is called the solar wind. Astronauts are able to see it in space, but only if they close their eyelids. You may see a flash when you close your eyelids. This is due to an energetic particle passing through your head, interacting with fluid in your eyes. The solar wind is a dangerous substance that can kill astronauts. A solar explosion between two lunar missions during the Apollo program would have killed astronauts had they been there. Radiation in space is an important issue. The solar wind is not a big threat to us on Earth because we are shielded by an invisible magnetic force that originates from the Earth's center. Magnetic fields can be created by converting motion energy into magnetic energy deep within the Earth. As the Earth rotates, it happens again. The magnetic field is created when the hot liquid metal flows around the solid core. It prevents the solar wind from entering the atmosphere of our planet. If the planet has a magnetic field, then the magnetic field will be responsible for sending the solar wind all around the planet. The magnetic field protects both the atmosphere and the surface of the Earth. Sometimes, big storms of solar radiation can mix up the magnetic force field. Then auroras occur over the poles when there is no magnetic force field. The solar wind would blow away the Earth's water and atmosphere, leaving it a dead planet. Mars is a lot like Earth. Mars was created the same way as Earth. Today, it is cold and dry. There's little to do. Why have both planets changed? NASA sent 2 robos to Mars in 2004 to see what they found. Spirit and Opportunity rovers surveyed miles of Mars' surface. They showed that Mars is a dangerous, dry desert with an atmosphere similar to Earth's. They did, however, find evidence that there used to be water on Mars. Mars was not always dry and barren. We have strong evidence that once there was water below the surface. It rose to the top and then evaporated. We can see ripples where water has flowed over sand. There was also water below the surface. It flowed over the surface. If Mars once had water, there was probably a lot more atmosphere surrounding it. What happened? It would have been made from the same material as Earth and had a liquid metal core in the middle, surrounded by hot iron. It would have had a magnetic field. Where did it go? Mars had a magnetic field early in its history. It was likely caused the same as on Earth. Mars is smaller than Earth due to this. It will lose more heat. A liquid core could become solid when frozen. Convection stops if you freeze the core completely. The magnetic field and flow stop. The magnetic field ceased to exist as soon as it stopped. Solar wind and water evaporation caused the atmosphere to be blown away by the solar wind. Mars became a cold and empty place. The rocky planets Mars and Earth, Venus, Mercury, and Mercury were all formed within 150 million miles of the Sun. The Sun roasted a different type of planet 4 times further out. These giants are made entirely of gas, and they have no solid surface. Astronomers have discovered more than 400 planets so far in distant solar systems. They are all huge and gas-filled. Jupiter, Saturn, Uranus, and Neptune are all gas giants in our solar system. They have thick, soupy hydrogen, helium, methane atmospheres. Why are the outer 4 gas giants, while the inner ones are made up of rocks? Here it's cold. The Sun is 500 million miles away at the beginning of the solar system. It was mostly water and gas, frozen into ice grains. The temperature was low enough to create solid snow in the area where planets were first forming. We think ice snowflakes were able to stick together and form giant planets. We believe that the planets grew so large because of all the ice and gas. The cores of these planets were about 10 times the size of Earth. These big cores were responsible for a lot of the gravity. These cores had such a strong pull that they were able to absorb all the gas surrounding them, creating thick, soupy atmospheres that traveled tens of thousands of miles. They grew bigger the more gravity they created. As the planets grew, they attracted more and more dust and debris. Here are the moons of Jupiter and Saturn. Jupiter and Saturn each have more than 60 satellites. Gas planets have unique rings. Saturn's rings are what make it different from other planets. Jupiter, Uranus, and Neptune all have rings. However, they are weak and difficult to see. They are there. Saturn's rings are most visible from a distance. There are rings on all 4 gas giants. Saturn's rings appear as a flat disk from a distance, but they are actually made up of thousands of small rings only a few miles wide. Cassini, the probe that flew over the rings, found billions of ice fragments and debris moving at speeds of up to 50,000 miles an hour. They are constantly hitting each other. Some of them become small moons. Saturn's massive gravity causes some of them to fall apart. However, they do not grow larger. Scientists have only recently begun to understand how Saturn's rings formed. The theory is that a moon-shattering comet knocked the moon out of its orbit and brought it closer to Earth. Saturn's gravity ripped it apart. All that stuff ended up in rings that circled the planet. The real mysteries of gas giants lie deep within them. Tens of thousands of miles below the clouds. This is where the action really begins. This is a place that goes against all natural laws. Most of the planets that we discover orbiting stars far away are gas giants. Jupiter looks small in comparison. Nobody knows what goes on inside the gas giant planets in our solar system or those far away. Jupiter's thick atmospheric layer extends down to 40,000 miles, and we can observe bands of gas moving rapidly at high speeds. This causes violent storms. We don't yet know what is happening far below the storms. NASA sent Galileo on a 14-year trip to Jupiter to discover the answer. On December 7, 1995, Galileo launched a probe through Jupiter's thick atmosphere at speeds of up to 160,000 miles an hour. It was slowed down by the parachute. The probe saw lightning and winds of 450 miles per hour in the clouds. It took 58 minutes for the probe to transmit data back to Earth. What happened to the Galileo probe? It didn't even hit anything. It kept falling into Jupiter's environment. As it fell, the pressure grew. It measured temperatures and pressures over 300 degrees above Earth. It can be heavy to go into the atmosphere of a giant gas and then deeper and deeper in this soup of liquid hydrogen. You would eventually be crushed under the weight of all the material. The probe, which only reached 124 miles before being crushed, showed scientists how Jupiter's interior looked. The dark core of the planet is still a mystery. Gas giants also have magnetic fields, just like some rocky worlds. Jupiter's magnetic field is 20,000 times stronger than Earth's and is so large that it reaches Saturn, which is 400 million miles from Earth. Jupiter's magnetic field keeps solar wind from entering the atmosphere, just like on Earth. Scientists found that Jupiter's magnetic field affected its moons. The volcanic moon Io is only 217,000 miles away from our planet. Io's volcanic activity sends a lot of dust and gas into space. Jupiter's magnetic field, which creates powerful belts and radiation, makes it even stronger. This makes the area surrounding Jupiter very active in many ways. You can listen to the interaction between the magnetic field and planets if you use a radio. Jupiter and Saturn are able to produce auroras even without solar wind. Because they are so large, they can create their own magnetic field. The auroras on planets with gases show them to have magnetic fields. How do magnetic fields form on gas planets, though? Gas planets are similar to Earth in that they use a liquid metal that spins around a solid iron core. These ice cores formed around dust and ice. We don't know exactly what is going on. We don't really know what the deepest parts are made of in Jupiter's inside. It's possible Jupiter has a liquid core or a solid one at its heart. We may never know. No probe would ever be able to go. It would take 44,000 miles for a probe to reach the planet's center. Galileo was destroyed by Earth's gravity before it reached the center. Gravity and heat influence the evolution of planets from their cores outwards. These are the two most important creative forces when it comes to building planets. There's still one thing that can have a major impact on the way planets look. Water is the key ingredient. Although it may seem that the planets are static and do not change, they are constantly changing. In our solar system, one planet lost its atmosphere. It became a desert. A planet became too hot, and it turned into the planet from hell. The Earth itself has changed. Water changed everything. You can see water on Earth when you look from space. After all, we are the blue planet. That must mean it is very moist. Right. Our world appears to be a large body of water at first glance. 3/4 of the planet is ocean. It's not true. Water makes up only 0.06% of the mass of Earth. Some of the water on Earth is in oceans, and some is trapped in the mantle. In reality, the Earth is made up of a dry rock. All the inner rocky worlds were formed close to the Sun. They started out dry. They lost any water that they had. The collisions of the Earth's massive structures were so violent that any water that was present would have vaporized and left. So, where did the water that is now on Earth come from? Now it's here. You can see that Jupiter, Saturn, and Uranus have a great deal of water inside. The moons are even more dramatic. At least half the water on the moons of Jupiter, Saturn, Uranus, and Neptune. There was a lot of water out there. How did it reach the Earth? It is very likely that some asteroids or comets remained in our solar system. They were far enough away from the Sun to be able to keep their water. These watery comets and asteroids flew in millions into the inner solar system. Some of them crashed onto our planet. The Earth absorbed the water from the asteroids over time. It is this water that covers nearly all of Earth. There would be no life without surface water. What about water, then? It's too much. Oceans would cover continents, Mount Everest, and be deeper. It's possible that the amount of water on Earth is what allowed us to evolve as a technological species. Around 4 billion years ago, a blizzard of comets and asteroids delivered just the right amount of water to Earth. Here's how the world as we know it today was created. It's also possible that this same process is happening somewhere else in our universe. There's a lot of water in the universe. It is certain. Hydrogen is the most common atom, followed by oxygen. H2O is a popular molecule in our universe. Water is found on every planet. We have not yet discovered another planet with liquid water. Scientists have discovered more than 400 new planets. Our world is not like any of them. We haven't yet found a planet that has the same mass, size, and chemical composition as Earth. But we'll keep looking. We know that our galaxy alone has around 100 billion stars, and up to 40 billion of them could have their own planets. But we will keep looking. We know our galaxy has 100 billion stars, and that up to 40 billion could have their very own planet. We are now entering the golden age for planetary exploration. We'll begin to understand the vast differences between the worlds we live in for the first time. This is going to be an exciting time. We know how planets form from the laws of physics, chemistry, and biology. Scientists believe it is only a question of time until we discover another Earth-like planet, formed from the exact same material and in the correct place with just the right amount of water. There are millions of planets waiting to be found in our solar system. Volcanoes can be destructive anywhere, from the ice-covered volcanoes on Saturn's moon Enceladus and the vast lava fields on Jupiter's moon Io to Earth itself. We would not exist if volcanoes did not exist. Volcanoes affect and change our climate. Volcanoes create and destroy existence. The spacecraft and observatories of today have revealed volcanoes in places we thought were dead. It was a big surprise to find volcanoes on a smaller object than the Moon. Could there be life on other planets if there are volcanoes? Volcanoes have the power to change our planet. They destroy old land and create new. They release gases that change the atmosphere. Our oceans are a deep source of oxygen. Volcanic heat is fueling bizarre new forms of life. Volcanoes are essential to the survival of life on Earth. We are now looking for life on other planets. We know that water is essential for life. We know that energy is needed. Volcanoes are a great source of energy. We may find life on other planets if we can locate volcanoes. This planet orbits Earth, the closest planet to Venus, a similar planet to ours. Venus and Earth share similar masses. Earth and Venus looked very similar 3 billion years ago, with new land, oceans, and atmosphere, and both planets being conducive to life. But something went wrong. The history of Venus diverged dramatically due to something. The history of Venus is very different from that of Earth. Venus has been firmly on the dark side for a very long time. Venus is our evil twin planet. Venus' surface is currently like a furnace. The surface temperature is 900 degrees Fahrenheit. Hot. The temperature is high enough to melt certain metals. You have no chance. Venus is a world of greenhouses. Its atmosphere is high in carbon dioxide. It acts as a blanket to absorb solar heat. Images of Venus' surface show a sweltering, desolate display. The planet has been wiped out by a dense CO2 atmosphere. Spacecraft orbiting the Earth provided the first clues. The CO2 was created by volcanoes. Venus' thick clouds were broken by radar, which revealed volcanic formations on the planet. The shield volcanoes of the Earth are similar to these formations. They get their names from the shape. These volcanoes are oozing, but for thousands of years. We began to study its landforms after we had mapped the entire surface using cloud-penetrating radio waves. Many of them looked familiar. We observed shield volcanoes similar to those in Hawaii. Radar images of Venus matched those of Hawaii's volcanic mountains. Venus used to be home to volcanic activity. The first time we saw a photo of Venus, we were blown away. We found a cratered volcanic surface. There are probably tens of thousands or hundreds of thousands smaller ones. Lava plains, which cover about 3/4 of Venus, are surface evidence from an ancient catastrophe. It could have been the home of life. Instead, it was consumed by fire. The volcanoes on Venus released trillions of tons of carbon dioxide into the atmosphere. The temperature increased dramatically. Oceans evaporated. Carbon dioxide can be absorbed into rocks on Earth. The ocean can absorb it. Venus has no water, and the temperature there is so high that the carbon dioxide can't even mix with the minerals. Carbon dioxide was released into the atmosphere by volcanoes ages ago. As time passed, fewer and fewer ways were available to remove carbon dioxide from the air. Volcanoes clean the planet. Earth may be the only planet that has life if Venus once supported life. Jupiter's moons are believed to be lifeless and frozen. As a mysterious cloud hovers over a lifeless and cold world, a mystery is revealed. Venus volcanoes have transformed the planet into an inferno. The discovery of volcanic activity on a similar planet to Earth was not a big surprise. But the discovery that volcanoes existed on the Moon in March 1979 was a shock. In this world, we had believed to be frozen and without life. The Voyager 1 spacecraft observed an arc near the Moon. It almost looked like there was another moon behind it. We scratched our minds, wondering what it could be. Everyone knows that Io's lifeless, dull, and uninteresting. Then people realized that it was a volcanic explosion. We found that the region is covered in volcanic ash. Geologically, it is extremely active. Volcanic eruptions are ongoing, and the sulfur that is released changes color depending on its temperature. It can be black, red, yellow, or orange. These images of Io's face resemble pizzas with different types of cheeses and olives in the places where there are small black spots. It is alive. It is still alive. More than 400 volcanoes are active. The largest pale is erupting from a giant lava lake. It extends about 400 kilometers into space. We would have an amazing sight if we were to stand at the edge of the lava lake and watch the plume shoot off into space. Io's explosions are so large due to Io's small size. The lava is not held back by gravity or atmosphere. Earth's volcanic eruptions look like fireworks. How can such a small moon be so active? Jupiter raises Earth's tides, just as the moon does. Jupiter causes solid rock tides to rise on Io. The orbit of Io about Jupiter is not circular. It can be closer or farther. Jupiter exerts a force of gravitation on Io. Jupiter's gravitational force squeezes and stretches Io every 2-day orbit. The ground can rise and fall by almost 300 feet. The extreme heat generated by this pounding creates enormous pressure and extreme heat wherever there are weak points in the crust. Lava erupts, volcanism on a planet scale. This is in contrast to Earth, where some portions are active near the plates or weak areas. This is the entire Moon. This is one hot spot. Io is the planet with the highest level of volcanism in the solar system due to the enormous power of gravity. Volcanic activity has taught us a new lesson. It showed us that volcanism can be driven by internal energy sources in a way that is different from Earth. Io is a lava world that is violent and extremely hot. It's hard to imagine anything living there. Our world is the only one where we have found volcanic activity. So we thought, Europa, it orbits Jupiter at a distance from the Sun of 500 million miles. From afar, it looks like a sphere of ice 2,000 miles wide. Close up, the surface looks polished. It's another story. Europa, like its companion Io, is slammed by Jupiter's enormous gravity. The surface is curved, with deep fissures and ridges. The images we saw of Jupiter's moon, Europa, looked vaguely familiar. They resemble Arctic ice flows, and they are exactly the same. Under Europa's thick icy surface lies a global ocean of liquid water. Europa's ocean, according to magnetic measurements, is 60 miles deep. Jupiter's gravitational influence heats up the interior rocky rock and melts ice on top. The core may also be heated by the tides. It's not absurd to think that there could be a boundary between an ocean of liquid water and a hot core. Underwater explosions on Earth are surrounded by a variety of life. The darkness may be complete on Europa. A crushing atmosphere of 2,000 Earth pressures is harsh, but it may be a cradle of life. Why not Europa if there's evidence of life? A source of energy. Volcanic activity. There are 3 things that you will find: liquid water, a universal solvent, and complex hydrocarbon chemistry. It would be hard, but not impossible. Europa is a place where life can be found at all extremes, such as searing heat, crushing weight, and total darkness. The life on Europa could be similar to ours in unexpected ways. Life would have to be aquatic if it exists under the ice of Europa, as there is no light. Sonar would be used by organisms that feed on the energy from the volcano. The emergence of life on Europa may be due to the volcanoes. Europa could be the norm, the standard for all planets that have life. Earth could be an exception. Europa may be a good model for all the moons with liquid oceans throughout the universe. By looking at the moons around Jupiter, our horizons are suddenly expanded by several billions. More than 170 lunar bodies are found in our solar system. This is a lot more than you might think when you multiply it by the size and scope of the universe. It is only necessary to have liquid water and an energy source. Both are possible and are everywhere. This is Saturn. It's twice as far away from the Sun than Jupiter. It also has volcanic satellites similar to Europa. These moons may be able to support life. Saturn has a ring system that is 600,000 miles wide. It's one of the strangest planets in our solar system. A staggering 62 moons, and one that has a secret. Enceladus, one of Saturn's lesser and farther moons, is a brighter and more reflective surface. It's been well known for many years that its surface is extremely reflective and brilliant, indicating a thick layer of ice. The Cassini probe made an amazing discovery, not on Enceladus, but when it visited the planet. The Cassini probe revealed a stunning discovery. A massive blue sphere backlit by sunlight and erupting in space. Is there conclusive proof of volcanic activity? Cassini's cameras zoom into the south pole of Enceladus, where these huge craters are visible. Enceladus is a large satellite that orbits Saturn. The tides cause the fissures to open and close. These fissures now are huge. These fissures extend hundreds of kilometers. When they start to open, a large crevasse would appear along their length at a speed of approximately 100 miles per hour. This would be an incredible spectacle. Gravitational forces were so powerful that they caused the surface of the ocean to contract and expand at incredible speeds. The heat produced by this helps to melt ice and create oceans below the surface. Conditions of water below the surface. This is the ideal environment for life. The temperature is ideal. Life would benefit. It would be like the seawater we have on Earth. The chemistry of water that we see erupting out of these fissures indicates it contains salt. It also contains organic material. We have therefore identified a place in the solar system where it is possible that life is present in the ice particle. Cassini detected complex carbon molecules along with liquid water. These findings suggest that life may exist in the mysterious moon Enceladus. It's possible that another of Saturn's satellites could also harbor life. Titan is one of the biggest moons in the solar system. It has a thick atmosphere made of frozen liquid water ice that is as solid as rock. Yet, we could also find evidence of volcanoes and even the tantalizing prospect of extraterrestrials on this planet. As evidenced by Io's raging conflagration and Triton's ice and nitrogen explosions, volcanoes are among the most destructive forces in the universe. It is larger than Mercury, with a diameter of about 3,000 miles. It has the most dense atmosphere in our solar system. The weather includes cyclones and winds. There are also lakes. The temperature is so low, liquid methane has replaced water and is loaded with compounds essential for life. Titan is one of the most interesting places in our solar system. It's a work in progress. It is the only lunar satellite with a dense and similar atmosphere to Earth because of the presence of nitrogen. It turns out that organic molecules are high in Titan's atmosphere. Methane gas reacts to sunlight to create compounds that are essential for life. Why does the methane gas not run out if sunlight converts it into organic compounds? Methane is plentiful in the air, but sunlight is known to quickly eliminate it. It shouldn't exist. Methane must be produced somewhere. Titan is emitting methane continuously. Cassini has seen what appears to be a crater. Infrared camera images reveal that the crater's surrounding materials are of various types. Scientists think that the green areas could be volcanic plains or lava ejected by Titan's interior. The boiling liquid that is emitted from Titan's volcanoes may be ammonia, or it could be water. Titan's volcanic activity emits ethane and methane. This is the likely cause of Titan's dense orange atmosphere and extremely dense cloud cover. The outgassing from Titan's volcanic activity is likely to be the cause of this atmosphere. Titan is a frigid globe. Titan's volcanoes need heat. Two sources of heat exist. Radioactive substances heat Saturn's interior, and Saturn's immense gravity caresses Enceladus, the Moon. Both forces are powerful enough to turn ice into liquid water and liquid methane gas. Volcanoes on Titan could give life here a chance. Chemical reactions that are necessary for life to exist require an atmosphere, solid surface, liquid, and heat. If Titan has life, then volcanoes would be able to provide all the necessities. It would be alien. It would swim in methane reservoirs and breathe hydrogen instead of air. It is possible that there are oceans of ethane, tidal pools, and volcanic activity. Maybe volcanic heat can produce enough energy for life to exist on Titan. This is a possibility, but not ruled out. We may not have to go so far to find signs of life. Mars is a world rich in volcanism and much closer to us. Volcanoes can be found all over the solar system. Planets like Io, Titan, and Triton have complex, volatile, and violent environments. We used to think that Earth was the sole planet with volcanoes, but now we see them everywhere. Aliens have yet to be found. Volcanoes are a perfect example of the power that can create and destroy. Both go together. If there were no volcanoes in this area, we wouldn't be here. The birthplace of all life is the volcanic cauldron. Volcanoes are responsible for creating new landscapes. The atmosphere is sown with complex chemicals. Replace the old with the new. If volcanic activity is linked to life processes, then where else could life exist? The answer may have been found in ancient times when the solar systems were still developing on a planet like ours. This is Mars, 3 billion years ago. Volcanoes erupted. The largest volcano in the solar system still stands. The cliffs that lead up to the volcano are more than 6 miles high. Even Mount Everest could be at ease in their shadow. Olympus Mountain is a massive mountain that covers an area as large as Arizona. The crater is 53 miles across. It takes millions of years to build a structure of this size, a time period that no volcano on Earth has ever had. Earth's crust moves constantly. The Earth's depths are in constant motion. The hot point is stationary. A single hot spot can force magma up to the surface and create a new island. The surface is moving. The island is moving away from the hot area and replaced by another volcanic island. Mars is different. Mars' crust is solid. The crust is a single, large plate. There is no tectonic movement. So, if you have a hot spot, it will just build and grow and become a bigger and larger volcano. Olympus Mons, which is huge today, is an icy remnant from a warmer, distant era. Olympus, an extinct volcanic cone on a dying planet, is now a veritable giant due to Mars' diminished atmosphere. The ancient volcanic terrain on Mars may one day be able to support life. Earth provides ample evidence. Hawaii's volcanoes have created enigmatic tunnels called lava tubes. These are formed by rivers of molten rock rushing into the ocean. Lava tubes are created when molten rock, basaltic magma, or lava at 2000 degrees Fahrenheit rushes into the ocean. Imagine an icy river that has a crust of frozen ice on its surface. The same thing, but the crust here is solid rock, and the river continues flowing beneath it, creating the cave, the lava conduit. Recent images suggest that Mars volcanoes could have created lava tubes. Lava tubes are likely to be found on any rocky planets with basaltic volcanism. After possibly millions of years of inactivity, these lava tubes could bring life back to the red planet. This will be our existence. Radiation is one of the biggest obstacles for future humans to overcome when trying to live on Mars. Incoming cosmic rays are lethal. As extinct volcanoes, the tunnels and caves on Mars could serve as a home that would retain air and protect us from harmful radiation. A long-dead volcano could bring new light to the world. Volcanoes can be both destructive and creative. The universe is vast and mysterious, filled with many wonders and secrets, awaiting discovery. One of the most intriguing and profound mysteries in the cosmos is the age itself. Subscribe to our channel if you're interested in watching amazing videos about the universe. Scientists have spent years studying the cosmos using various tools and techniques. They have estimated that the universe is 13.8 billion years old. In the early 20th century, astronomers began to realize that the universe was expanding. The concept of an expanding universe was first suggested by Belgian astronomer Georges Lemaitre. It wasn't until Edwin Hubble's work in the 1920s and 1930s that this idea became widely accepted. Hubble's observations of distant galaxies revealed their rapid movement away from us. The farther away the galaxy was, the faster it moved. Hubble's law, or the relationship between distance and speed, suggests that the universe is not static but rather expanding. If the universe is expanding, it must have once been smaller. This realization led scientists to wonder how old the universe was. Models of stellar evolution were used to make the first estimates of the age of the universe. Scientists were aware that stars age in a predictable way, so they believed that they could estimate the age of our universe by studying their properties. These early estimates, however, were plagued with uncertainties, as we did not fully understand stellar evolution. They ranged from a few million to several billion years. In the 1960s, a more accurate method for determining the age of the universe was found. Two astronomers named Arno Penzias and Robert Wilson had discovered a faint radiation in the sky. The CMB, or cosmic microwave background radiation, is believed to be the remnant radiation of the Big Bang. The Big Bang is the event that marks the birth of the universe. Scientists can now estimate the age of our universe using the CMB, which was discovered by scientists in the 1960s. Scientists could learn important information about the early universe by studying the CMB's properties, including its temperature and composition. In the coming decades, this information could be used to estimate how old the universe is. Scientists are improving their measurements of the CMB to better understand the early universe. They are also developing more complex models of cosmic development, taking into account the effects of dark matter and dark energy on the mysterious substances that make up the vast majority of the universe. Taking into account the effects of dark matter and dark energy on the mysterious substances that make up the vast majority of the universe. Combining these observations with models, scientists were able to estimate the age of our universe at 13.8 billion years. This estimate is confirmed by independent measurements, including observations of supernovae at a distance and the structure of the large-scale universe. The age of our universe is a well-established fact in cosmology and has profound implications for our understanding of the cosmos. The age of our universe tells us about the fascinating and long history of our universe, going back billions and millions of years to when the universe was a small, dense, and hot singularity. It tells us that the stars and galaxies we see today were the result of billions of years of cosmic development driven by gravity and the interaction between matter and energy. The age of the universe also has implications for our search for life beyond Earth. By studying the conditions that led to life on Earth and the diversity of life forms on our planet, we can gain insight into the kinds of environments and conditions that might be conducive to life elsewhere in our universe. According to some theories, the universe is only one of many parallel universes, each with its own history and unique properties. If a multiverse exists, the age of the cosmos tells us that there is plenty of time for many different universes with their own unique histories and futures to exist. The age of the universe reminds us, finally, of the beauty and wonders of the cosmos. From the cosmic microwave background left over from the Big Bang to the stars and galaxies dancing across the night skies, the universe is an incredibly complex and rich tapestry that is both inspiring and humbling. The age of the universe is an amazing fact with profound implications for our understanding of the cosmos. It tells us about the origins and evolution of the universe, the possibility of extraterrestrials, the nature and beauty of the cosmos. The age of the universe will continue to be a crucial piece of information as we explore the mysteries of our universe. It is not clear what the final fate of the universe will be. The universe is expanding today at a rapid rate, but it is unclear how the universe will end up. Some theories claim that the universe is going to continue expanding forever and eventually become a cold, dark place without stars or galaxies. Some theories predict that the universe may eventually collapse in on itself, leading to a second Big Bang and a brand new universe. The age of the cosmos tells us that we live in an exciting time in cosmic history, no matter what the final fate of the world may be. We are able to study the cosmos at a moment when it's still changing and evolving, when galaxies and stars are still merging and colliding. We can learn about the nature of the universe by studying its evolution. We can also gain insight into the possibility of intelligent civilizations elsewhere in the universe by looking at the age of the cosmos. If intelligent life can develop on other planets and life is relatively common in the universe, there could be many older civilizations. The age of the universe has implications for our search for life beyond Earth. We can learn about the conditions that led to life on Earth and the diversity of life forms on our planet. We can gain insight into the kinds of environments and conditions that might be conducive to life elsewhere in our universe. According to some theories, the universe is only one of many parallel universes, each with its own history and unique properties. If a multiverse exists, the age of the cosmos tells us that there is plenty of time to create many different universes with their own unique histories and futures. The age of the universe reminds us, finally, of the beauty and wonders of the cosmos. From the cosmic microwave background left over from the Big Bang to the stars and galaxies dancing across the night skies, the universe is an incredibly complex and rich tapestry that is both inspiring and humbling. The age of the universe is an amazing fact with profound implications for our understanding of the cosmos. It tells us about the origins and evolution of the universe, the possibility of extraterrestrials, the nature and beauty of the cosmos. The age of the universe will continue to be a crucial piece of information as we explore the mysteries of our universe. Subscribe to the channel, put likes, write comments. Goodbye.